Welcome to Brain Vision.
In this problem, we have to determine that the ratio of the maximum values of the shearing stress and the normal stresses in the beam is equal to twice h upon L. The given length of the beam AB is L and the depth of the beam is H. Now area of cross section is B multiplied by H. B is the width of the beam and H is the depth of the beam, and the section modulus of cross section is calculated as 1 upon 6 BH square. Now due to the symmetry of the beam, reaction to the support C and D are equal, so RC is equal to RD is equal to WL upon 2. Um, Now the shear force at A, that is VA, is 0, and this shear force at A right, that is VA right, is minus WL upon 4, and the shear stress force at C, BC, is WL upon 2 minus WL upon 4. Shear force at D, that is VD, is this is equal to WL upon 4. Force at D is minus 3WL upon 4 plus WL upon 2, that is minus WL upon 4, and the shear force at BB is minus WL plus WL upon 2 plus WL upon 2. This is equal to 0. Now the um, bending moment at A, this MA, is 0. Bending moment at B is minus WL into L upon 2 plus WL upon 2 multiplied by 3L upon 4 plus WL upon 2 multiplied by L upon 4. This will be equal to 0. Bending moment at C is minus W L upon 4 multiplied by L upon 8. It is minus WL square upon 32. Bending moment at D is MD. Sorry, minus 3WL upon 4 multiplied by 3 upon 8 plus WL upon 2 multiplied by L by 2, that is equal to minus WL square upon 32. Now the maximum shear stress is tau m is 3 upon 2 multiplied by V max upon A. So let us substitute the values of V max is WL upon 4 and A is BH. This is equation 1. So this is equal to 3WL upon 8BH, and the normal stress is sigma m is m max upon S, So we have mx is w L square upon 32, s is 1 upon 6 bh square. This will be equal to 3 w L square upon 16 bh square. Now let us calculate the ratio of maximum values of shearing and normal stresses. That is tau m upon sigma m is equal to 3 W L upon 8 BH upon 3 W L square upon 16 BH square. So this is 3 W L upon 8 BH into 16 BH square upon 3 W L square, that is equal to twice H upon L. Therefore, the ratio of the maximum values of shearing and normal stresses in the beam is equal to twice H upon L is proved. Now, in the second one, we have to determine the depth and width of the beam. So, given length of the beam is 5 meter, load is 8 kilonewton per meter, maximum shear stress is 1.08 megapascal and the normal stress is 12 megapascal. So from part A we have tau max, that is the maximum shear stress upon the normal stress, is equal to twice H upon L. So we have 1.08 upon 12 is equal to twice H upon length is 5. So from here we will get H equal to 225 mm. Therefore, the depth of the beam is of the 225 millimeter. Now the width can be calculated from equation 1. Equation 1 is m is equal to 3 WL upon 8 BH. So we have tau max is 1.08 megapascal converted to kilonewton, that is 10 to the power 3 kilonewton per meter square upon 1 megapascal. 3 W is 8 kilonewton per meter into L is 5 meter upon 8. B is 225 B H is 225 millimeter into meter, so 1000 mm, that is equal to 1944. B is equal to 120, so B is equal to 0.0617 meter into millimeter. So B is equal to 61.7 mm. Therefore, width of the beam is 61.7 mm.